Oke, Assalamualaikum warahmatullahi wabarakatuh. This is Kemal for Project USA. So we have two people in our group. Okay, unfortunately, so me and Nurul. So I'm in charge of the binary search tree. So let's go right into it. So here note we have no for the number, student number, name for the student name, this is for the grade, this is for the total of the grade, this is for the left right parent is for the binary tree, and next and pref is the linked list. It's structure, set node for the print, for the print of the node, so this, so let's say root for the, if I'm using binary tree, head or rear, if I use a linked list, and choice for differentiation if I using binary tree of linked list. If binary tree I use 1, if linked list I use 2. So n is for the end of the menu, so how much menu appear. Okay, so here the list, like if we initialize the C here, we will for the choice, let's say I1, then it means it's going to choice. So if the choice is equal to 1, it's going to be binary tree. Okay, so let's go to the menu. Choose which one you wanted to store the data. So I'm going to choose binary search tree. Okay, what you want to do with the list. So let's say I want to create calculation. Choose which grade you want to calculate. Lab exercise. Say total for the option number 1. Lab exercise is 235. Number of student, average percentage. Okay, so let's say I want to add a student. Student number, let's say 12, name Asa, 12, 12, 12, 12, 12, 12, or for the grade. So let's say I want to display all of the student. So right here, have you got Asa? Is it already on the list? Wait a minute. Here we go. It is on the list. Okay. So let's say I want to search the student by number. So in binary search tree, enter the student number you want to search or delete. So let's say 12, right? Because it's Asa. Okay. Oh, here, this is the detail of the Asa. Asa 12, 12, 12, 12, 12. Okay. Let's say I want to delete student Asa. Okay. So 5. And then the student number you want to delete 12, right? Asa is 12. So let's check if Asa is already deleted. So search student by number 4, and then the student number you want to search or delete 12. No record made. So there is no record. So it is successfully been deleted. So let's end. If you want to end, say end. Press 6 and it's going to be end. So here, what are we? I'm going to explain the function a little bit. So here, list. In the list, add node. Let's say add node for the binary tree. If root is equal to s, if root is than null. So if the root is empty, no travel is equal to root 10. So it's determined. So if the new node is less than travel, the student number is going to place in the left. If it is bigger, and it's going to be placed in the right. So because we search by the number, right? Because the unique for each student is the number, so we search by the number. I think it's more better that way. So it's more easy to differentiate. Okay, travel equal right. That's for the set of the add a node. This is for display node. If I want to search, so if travel is equal to null, or we found the number we search, so we turn the node. If the number is less than travel number, the node that we currently been searching, we search node in the left side. Else, if the search number is bigger, then we go to the right, travel right. We chop it into little pieces. That's for the binary search tree. So for say this is the implementation. So if choice is equal to 1, we use root. Else if choice equal to 2, we use the head. So different. So for del node, uh, for binary search tree, we just delete the if let's say I going to delete the node, if it has a child, it's going to pick the most leftmost right child. So the leftmost from the right side child. So it's going to uh going a little bit a lot. So I don't think it's enough time to explain it all. Yeah, I already gave the comment here, so maybe if you want to check also. Okay, because it is a lot. Like yeah. So okay, double total. We search total. It's going to be total for the left side plus the lab exercise for case 1. There is 8 case 1, and total for the right side plus. So we chop it to smaller problem. Same the size. We calculate the size for the left side and then for the right side. If we get to the bottom with the most the the bottom one, if it is called null, it's going to return 0. So it's going to return the size. For average, it's basically the same. Total by the size. For the percentage, so 1, 5, 6, 7, because the maximum number is 10, so we're going to times 10 times 100 and divide 10. To 3, because the maximum is 15, it's going to be like this. 4, it's going to be like for 13, and because 8 is maximum for total, the maximum is 100, so it's time 100 divide 100, so it's going to be 1. So it doesn't really matter. Here is display the total. So here we see the different for choice 1 and choice 2. We use root and head. So yeah, that's basically it. Here is the initialization. So this is for the initial menu. For the choice, it will determine which for the create list it is. So if it's 2, it's 1, it's going to binary search tree. If it's 2, it's going to be linked list. So if it's neither of those, we're going to ask them again. Here is the add node. So here, okay, that's all I think. Thank you. I don't want it to drag along. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. Myself Knowledge Matani. Before Kemal described the binary tree for our project, now I will continue our project for linked list. Here if we see the node next into previous we used for linked list function, next refer to the next node in the linked list, and this node, like all of the nodes in the list, has a next and a previous, and the previous of this node refer to the original node, next refer to the current node as long as the previous is non-null. Previous refer to the previous, next refer to the current node as long as it is the non-null. So next, if we see in this part, we need to print name, number, lab exercise, test 1, lab, final, assignment, quiz, project, etc. For this part, we have a class list, and in this list we need to select two, binary or linked list. If we run this program, here in the initial menu we need to choose binary or linked list. For my part, I need to choose 2. If I select 2, it show the menu list, grade calculation, display, add, search, student, delete, and end. Next here, else if we choose the 2, then our head is equal to null, head store and rear also store, then store going to be next in store, and previous also going to the store. Else if rear rear go to next and store going to previous and is equal to will be rear, and then again rear will go to the store, and store will be the next and going to back our head. So here have the add student list, and here have the search and delete. If choose, there have the link list will be choose if choose 2, then search node will be head and head to the student, and going to print the search student or delete student number. It show the print. Then and here while grade calculation is similar like the binary tree with just 2 options, and our functionality will work same as binary and linked list chunks. Here have the else if we choose the 2, I mean linked list, then it will the travel will not null, and then travel will be print, and travel is equal to when it is print then go to next. While travel is not, then back to the head. Menu list we need to grade calculation, and integer menu is 1 and inline, then it is the grade calculation, display, add, search, delete option and so on. Then Swiss menu also display, add, show, break and thank you, and the initial menu we need to choose integer, choose 0, and then here of the if we not choose 1 and if and we not choose the 2, initial menu it show the binary tree or linked list. Here we have only 2 options is 1 and 2 binary, so we should select between 1 and 2 and then return the choice, and here up the node adding, grading, and that's all about our code for linked list. So I used linked list, then I need to, if I select the number 1 for menu list grade calculation, here have the lab exercise according to our code, then test 1, test 2, final and so on. Suppose if I want to choose one lab exercise, then it show it is a total for the number 1 is total student and average, and also the percentage it show, and otherwise if I want to add, if I search student of the number, if I choose 4, then it will be student number wanted to search or delete. Okay, student number like 15 choose, it show here of the 15, so it show the name is anonymous, number, his ID number and so on, and his marks. And if we number 3, if I add some student, so please enter the student number like 16, student name like Nabila, lab exercise grade like 16, 12, 17, 19, 23, quiz grade is 20, project grade is 27, and see here have the also add the student. And here have the, if we delete the student, if I choose 5, then search or delete, it will be 5, enter the student number. If I delete the number 15, the 15 also the deleted. And if I want to display all the student and press 2, see here have the every students, number 2, number 3, number 4, every students lab exercise, test lab and total percentage it shows. So here have the if we press N6, and our project will be finished. So that's all about our project, binary tree and linked list implementation on our project.